So sometimes when we have these situations where we're trying to model something, it's helpful to draw a diagram. Now, this problem says Anna and Emmanuel start at the same intersection. So they start at a certain spot. Anna walks east at 4 miles per hour. Okay, so that's Anna. And while Emmanuel walks south at 3 miles per hour. And this is Emmanuel. They are communicating with a two-way radio that has a range of 2 miles. Okay, so and then the question is, how long after they start walking will they fall out of radio contact? So here's what you want. That's the distance between Anna and Emmanuel, right? He's walking east, she's walking east, he's walking south. And so the distance is the straight line between them, okay? That creates a triangle, right? This is a little Pythagorean triangle. Now, they tell us 4 miles per hour. That doesn't say how far she walked, right? It depends on how long she's walking. And so that's what we're trying to figure out is time. How long? So we'll put T for time. So Anna's distance is going to be 4T. If she walks for an hour, then she will have walked for 4 miles. If she walks for 2 hours, she would walk 8 miles, right? All right, and then Emmanuel, his time or his distance is going to be 3T. Okay? And again, if he walks for an hour, he's going to go 3 miles. If he walks for 2 hours, he's going to go 6 miles. All right, and so our distance is a function of time. And this is based on the Pythagorean theorem. It's because you have a right triangle. And now that we have everything in terms of distances, we can make this relationship. So we can say d of t squared is equal to 3t squared plus 4t squared. And then that's going to give us 9t squared plus 16t squared, which is going to be 25t squared, right? Now, that's what d of t squared equals, right? That's their distance. So, and you might be saying, hey, wait a minute, this isn't even a linear function because it's quadratic, right? It's not a linear function right now, but what we're going to do is we're going to take the square root of both sides. Now, we've done that before, and you might be saying, hey, wait a minute, you didn't take the plus or minus. Yeah, because my distance is going to be positive, so I don't have to worry about a minus situation. And so I get 5t, right? If I take the square root of 25t squared. So now I have the distance as a function of time. And I want to know when that distance is going to be 2 miles, because that's how far apart they are. So I want to know, when does 5t equal, when is the output 2 miles? And so I divide by 5, and I get 2/5. That's 2/5 of an hour. So 2/5 of an hour, which a fifth of an hour is 12 minutes, so 24 minutes. So if they walk for 24 minutes, they'd be able to talk, but then if they go a little further, they won't be able to talk. Okay.